continuous flow graphs. Okay, so we have mostly talked about batch graphs, and I have few videos based on for with respect to continuous graph also. But we are going to talk about some advanced concept in continuous graphs and some use cases, real-time use cases wherein those advanced components may be playing a very perfect role to solve those real-time questions. Okay, so let's talk about kind of revision of continuous flow fundamentals basically. So today we are going to talk about those fundamentals, and then thereon we are going to talk about multiple more videos, and we will take a, an application, a project, and then we are trying to utilize those advanced concept or advanced components to solve the real-time use cases. Okay, so now let's understand what is the difference between batch graphs and continuous graph. Okay, so as we know, right, the batch graphs are kind of majorly long running. They have a two they have a long time to process actually. So therefore, we don't expect those. There are lots of batches, right, in our projects, right. We have millions of data to be processed, and you know so in those use cases, we use the long batch graphs, and they are more majorly long running, and there is a lot of waiting time involved. So mostly the processes are daily processes, or some of them are weekly processes. So we try to the data is uh, arrives once in a day or once in a week, and then finally we process our batch, okay, to load those data from the source system to the apply the transformation, enrichment, and so on, and to the data warehouse kind of thing. And until then, the downstream process has to wait, right? So uh, there is a lot of time to process basically, that is batch timing, right? So we cannot deliver real time to the downstream process. That has to wait until then, right? So but uh, unlike this batch graph, continuous graphs are continuously running actually. They have a real time response. Okay, they keep on running, and as soon as the data arrives, it would react on those data and it will process then and there. Okay, so that is the fundamental, difference between those two processes. So we will not have a stop, right? So it will keep on running, but in batch graph, batch will start, and then after processing everything, this is going to be end. Okay, and then next day, maybe if the frequency is daily, so the next day the batch will start, and then you know the time it takes from starting and end is called batch timing, right? Full batch timing. So but in continuous graph, it's keep on running, and the response will received on real time. So this is one difference. Best for analytical applications. So I talked about, right, the data warehousing applications. They have a lot of data to be processed and to be loaded in the data warehouse. Then there will be a query mechanism, or maybe SSR reports, other reports like MSTR reports, or Tableau reports, or all those kind of reports can be sit on the data warehouse, right? So this best kind of best graph, right, will be used to process those data and load into the data warehouse kind of application, right? But this is best for real-time transactional application. So this continuous graph is like data is received, and then it is processed and loaded into some database. It's kind of transactional database. There is not much processing transformation involved, but right, so it's a kind of quick running graphs, and then the data is maybe loaded into the data warehouse, or maybe processed, and maybe processed and offered to the downstream application then and there. Okay, so third difference could be like run limited number of times in a day, right? Limited, I think here it is limited. So it's maybe twice a day, or maybe mostly is frequency is going to be once in a day, or some of them could be once in a week, or maybe once in a month for a monthly processing, or hardly it's going to be a quarterly process. Some processes are quarterly, right? So maybe a 3 months in a once in a 3 months kind of process may be also there. Okay, there are limited number of processing, but this continuous graph can run forever, or until we can, you know, or it is a scheduled shutdown or a forceful shutdown. Maybe shut down or stop at specified time. Otherwise, it will keep on running. So, what kind of continuous graphs we have? We have a request response mechanism. Like the client will request the from to the server, and server will act upon that request and prepare the response and send back to the client. So that kind of application can be you know continuously running. So we don't know when a particular request can come. So we will keep on running, and as soon as the request comes, our continuous graph will subscribe to that request, or it will accept that request and then act upon that request based on the context, or based on the nature of that request, and response will be prepared and sent back to the client, okay, back. And also it could be a publish subscribe mechanism, right? So uh, instead of client waiting for the response in real time, what it can be done is like client would request uh, send the request, okay, and that request can be put into the some kind of queue, maybe Abinitio queue or JMS queue, right? Or maybe a Kafka topic. So that the request can be pipelined into the queue, and then a particular subscriber, right, or maybe multiple subscriber uh, can keep on looking at that topic or queue, and then they will read that topic or queue and then act upon that, and then they will process the request, and then they also can send the request into the as a form of queue, or otherwise, right? So this is kind of publisher subscriber mechanism. So request can be subscribed and then processed, and then the response can be put in the form of you know a queue, or any other type of, maybe in the file system if we can place the data into the file. So so there could be two types of things like continuous graphs. So when so we have the context, right? We know what does continuous graph are. So in what kind of situations, right? When we use the continuous graph. So first is like input is not a fixed set of data, but a regular flow, perhaps coming at rates near real time. So there, if there is a near real time data, it's keep on coming. There is no fixed data set, right? We say like it's a 5 million data and some, right? In unlike batch graph, so request can be in the size of, there is a unit of work in the continuous graph actually. It could be a one record also, or it could be a set of 5 records, it could be a set of 10 records, right? In case of publish subscriber mechanism, wherein we have its compute point and checkpoints, right? So in that case, there won't be a fixed size of data, but there could be a continuous data coming in. It's a continuous flow of the data coming into the system, and the results are not made available before the large batch of data accumulate. Low latencies are desired. So there is no waiting time basically. So the expectation is like as soon as the request comes, we need to have response, or as soon as the data is there in the pipeline or in the queue, the request must be processed, and the data sent to the downstream processing, right? So publishing must be happening at with the low latencies basically. Okay. So the overhead of graph startup and shutdown to process small batch of incoming data dominates processing time. So we talked about batch graphs, right? So batch graphs, there is a lot of startup time and shutting down time. Right? They lookup creation happens, and those all those things, the enrichment and filtration, validation, everything. All those activities we don't want, right? So in those activities, we will have a startup time if we use the batch graph and all, right? Shutdown time. So that time is very very huge. So if that time is huge with respect to the processing time, the processing time is, let's say, 1 minute, and that startup time and shutdown time is are, let's say, 5 minutes. So it's very very huge with respect to the processing time, because the real time processing happens in 1 minute, but all those overhead, right? The overhead and the time consuming by the overhead is huge. So we don't want to go with the batch graph. We will instead use the continuous graph, right? Recovery model suggests it. Okay, in the sense of you need a recovery based on group of record, not based on group of components. So this is another concept, right? If we have a group of components, that is called phases, right? In the case of when we intend to avail the recovery of a particular processing, right? So we will go with the batch graph, and the recovery should be based on the number of components, right? Then we go with the batch graph, and we will put the components in phases with the checkpoint, right? So in that case, we can avail and achieve the necessary recovery, right? Rather than processing everything again, right? We can make sure that recovery happens at the particular checkpoint, right? But this can be case the amount of work per record is huge, right? So you need to recover based on group of records. In the continuous graph, we will have a recovery based on group of record in the sense of unit of work. So between the checkpoints, we can have a recovery. So between the checkpoints, we can avail the number of checkpoint, the time-based checkpoint or number of record-based type, right? So that we can make our subscribe component to emit the checkpoint on the basis of number of records and and the number of ticking time, number of times. So how much time it left, right? So maybe after 20 minutes, or maybe 20 minutes plus 100 records, right? So that kind of checkpoint mechanism we can emit from the subscribe component, and based on that we can decide the recovery also. Okay. So your and the fifth requirement could be like your application design is inherently continuous. For example, service graph. If we have a service graph, in the sense of the client cannot wait for it, right? For the response, it should not be like we have placed the request now and we will get the response tomorrow. So it's not going to happen like that in service graph, right? So request is sent, and the client is waiting for the response real time, right? So if that kind of situation is there, we use should go with the continuous graph. So these are the some context and use case scenarios wherein we can think of our data and the expectation and the frequency of data and the arrival of the data, the nature of the data, nature of the response, nature of the latency, you know, and the processing time. We can think of using the continuous graph. So how major components will behave, you know, in the continuous flow processing, like let's say sort components. How sort will behave in batch graph is like we will have a total number of records to supply to the sort component, and then it will start, we will supply the max score value, and then it will start sorting those number of records. Everything should be sorted, and after that the number of records should start flowing after up from the sort component, right? But in the case of continuous graph, we will have the records within a unit of work, in the sense of in each within in a single checkpoint, right? Between the two checkpoints there will be, let's say, 10 records. So all those 10 record will be sorted by the sort component, will be and then the next checkpoint will be emitted, right? So all those 10 records sorted and placed into the output port, and then the checkpoint is getting emitted, and then the sort will start working on the next checkpoint, right? Next unit of work. So this is how sort behaves within a continuous graph. And how rollup behaves in continuous graph, I like continuous rollup. in memory rollup we talk about, then it will produce the output based on each unit of work. So based on number of unit of work, let's say we have 10 records in a particular group, but in a unit of work, so the grouping happens, based on the uh, unit of work, based on the number of records between checkpoints. Okay, so here in I talked, right, 10 records. So after 10 records the next group starts, right? So, but also rollup can be continuous rollup can be configured. There is a continuous rollup, right? So it can also be configured based on key group also, key or as well as the unit of work, right? And the database components is like database components. The commit happens at the end of each unit of work, right? So there is no commit table, there is no commit number as such in the database components which running in the continuous graph, but there is a commit happens based on the unit of work. So if checkpoint comes, the prospective database component must commit the data and commit the changes into the database, and then the next unit of work should start and try to process it. Okay, so maybe the each different contents graph components we are going to understand. We will have a multiple advanced components also, which are very useful with respect to database processing and the use case with respect to database and other processing. And we will try to simulate, compare the behavior between batch graph and continuous graph, right? All those components, how that scenario can be solved easily in batch graph, and there is how it is different in continuous graph, right? That kind of context we are going to see in coming videos. Okay, thank you so much. Please subscribe my channel, and we are going to see many more videos like this. Okay, thank you so much.